Hello class. Today we're going to go over the second part of the handout. We're going to go over linear equations. And so we're going to start this off by going over the three different types of linear equations. Alright, you can have the linear equation could be independent, which means it has one solution. It could be dependent, in which case it has more or has an infinite number of solutions. Or it finally could be inconsistent. And if it is inconsistent, that means it has no solution. Okay. And so typically what we do for these is that we work the equation down trying to solve for x. I'm sure everyone's done that before. And if you get yourself to a point to where you have an untrue statement, that's usually a sign that the solution is inconsistent. Or if you get something that is simply a truism, such as 1 equals 1, then that would be indicative of it being dependent and having an infinite number of solutions. Alright, whereas of course if you work it out this way, work it out and you get where there's only one solution, well, clearly you have an independent equation. I don't really expect you guys to have independent, dependent, and inconsistent as part of your working vocabulary, but I do expect you to know that any of these equations could have one solution or an infinite number of solutions or no solution. Alright, so let's take a look at this first one. Alright, so we're going to go ahead and subtract 35x from both sides because we want to move this over. Alright, so it makes that one 0, this one is 0, plus 5. And so we get 5 equals 0. And when does 5 equal 0? Well, the answer is never. 5 never equals 0 because they're just two very different numbers. So clearly this has no solution. Okay. Alright, so let's go ahead and move to the next one. I do encourage you to hit the pause button in between each of these and try and see if your work matches the work that I'm doing, because we want to make sure that we get plenty of practice while we're doing this. Alright, so what we're going to do here is first we notice that there is an x term here and here. So we're going to go ahead and add these two guys together. And when we do that, we get 21x equals 21x. And we're going to subtract 21x from both sides. And I'm just changing the color so it's a little more clear what's going on. And we get 0 equals 0. When does 0 equal 0? Always. It always equals 0. And so we would say that there is, in fact, an infinite number of solutions. And you could even put some test numbers into here, here, and here, and you'll find that it doesn't matter what value of x you pump into the equation right here, you're going to get an answer that is correct. So any value of x will satisfy this equation here. Okay. Alright, and so let's go on to C. Alright, so we've got 8x plus 13 equals 21x. So we want to get the x's to the left, and everything that's not an x, move that over to the right. So let's go ahead and subtract 21x from both sides, and also let's go ahead and subtract 13 from both sides. Okay, and when we do this, we have 8x minus 21x right here, and then that equals negative 13. So basically we have negative 13x equals negative 13. Divide both sides by negative 13. And we end up with x equals positive 1. All right, so that's one solution. And that's our answer. Okay, so on this next one, we're going to do it one way, and it's going to seem to indicate something, but the answer is really going to go in another direction. So let's go ahead and do it this way first. We notice there is an x here, here, and here. So why don't we just divide both sides by x, right? Get the x's away from one side, and when you do that, you end up with 5 plus 3 equals 30. 8 equals 30. Of course, that's not true. So this would indicate that there is no solution. But that's not right. And we're going to go over why that's not right in just a second. But to show that's not right, let's work this a different way. Okay, we're going to come over to the side here. We're going to work it again. This time we're going to combine 5x plus 3x. And when we do that, we're going to end up with 8x equals 30x. And so now let's go ahead and move everything over to the left-hand side. Make that a little more pronounced. So that is definitely an equals sign. Okay. All right. So clearly on the right-hand side, we've got a 0. And then on the left-hand side, we're going to end up with 22 or negative 22x, and we divide both sides by negative 22, and we find that we have x equals 0. Right? You can plug this in and over here, and you'll find that it does in fact work. Right? You'll end up with 0 equals 0. So there is one solution. So the question you should be asking yourself is, well, why did we get an inconsistency here? Why did we get something that seems to indicate that there is no solution? And the answer to that question lies in what we divided by here and here. We divided both sides by x. We divided everything by x. But what did we find that x equals? We found that x equals 0. So what did we do? We divided by 0. Don't want to do that. Okay, so that's why you have to be careful when you're dividing something by an unknown. That's kind of why I did it this way. I wanted to illustrate that when you divide by an unknown, be careful. You might want to double check. Make sure that unknown you're dividing by is not in fact 0, because as you can see right here, strange things happen when you divide by 0. Okay, so now let's go ahead and solve the following linear equations, and we'll plot the solutions on the number line. So these equations have what's called are called rational equations, because we've got one equation divided by another. And an easy way to solve these is simply find what's called the lowest common multiple. And so you can see here, 3x times 5 will get us 15x, which is the same as right here. So luckily the lowest common multiple here works out quite nicely. And we'll write 3 times x times 5 over here. Right, this is going to each of these. And note that even though these look different here and here, they are in fact the same number. Okay, so note on the right hand side over here, 15x, well, that cancels out with 15x. And now on the left hand side, we're going to go ahead and distribute this guy here to this term and to that term. And so when we do that, we've got 3 times x times 5 there. And then we've got the normal equation. Minus, let's go ahead and right, because we've got to write it twice because it's going to both of them. And that all equals 2. Alright, so now we're going to go ahead and cancel out what cancels. So 3 cancels with 3, x cancels with x. Over here, 5 cancels with 5. And so we're able to do these easy cancellations because we utilize the lowest common multiple. That's why we find the lowest common multiple. Alright, so right here, now we're left with the 5 and the 2. 5 times 2 is 10. And then minus, we've got just left with 3x times 8. 3 times 8 is 24. And that all equals 2. Alright, so note that, whereas before we had the unknown written in a couple places, now we have it right here. And it's a very nice equation to work with at this point. Alright, so now we just subtract 10 from both sides. And so we have negative 24x. Let me move this down. Negative 24x, and that equals negative 8. Divide both sides by negative 24. And we'll find that we've got 8 divided by 24. Note that it's now positive because a negative divided by a negative is just a positive. 8 goes into 24, so we can rewrite this as simply 1 over 3. And so that's our answer, 1/3. And then we're going to plot this rational number right here. So okay, right there. Alright, so that's our number for A. Well, we'll go ahead and write A right there so we know which one it went to. Let's go ahead and go to the next one. Now we're at B. Let me go ahead and shrink that down a little bit. Alright, lowest common multiple. So we've got an x, a 5, and a 3x. We want to find the lowest common multiple. So note that the x is repeated. Here and here. So we're only going to have the lowest common multiple. We're only going to write the x down once. So our lowest common multiple is going to be x times 5 times 3. Alright, that's it. So we're going to do that on both sides. And then over here, x times 5 times 3. Good. All right, so let's go ahead and work this through. Taking note over here, we've got an x and an x canceling. And so we're left with 5 times 3 times 3. 3 times 3 is 9. 5 times 9 is 45. All right, and so now we're going to have 2/5, and then 5 over 3x. Let's go ahead and put in our lowest common multiple now. Okay. And so we got a 5 canceling with a 5, and we've got a 3 canceling with a 3, and then the x canceling with the x. Okay, and so now this is simply going to work its way out. So we've got, again, 45, 2 times x times 3, that's 6 times x, plus 5 times 5, which is 25. All right, so let's go ahead and rearrange this. We subtract 6x from both sides. So we have negative 6x equals negative 45 plus 25. And let's simplify that right-hand side. Okay, divide both sides by 6, and we get, or negative 6, and so we get 20 divided by 6. And note that's the same thing as 10 over 3. Okay, so 10 over 3 is the answer. We want to go ahead and plot that on the number line. Note that we got to figure out which two whole numbers this is between. And so it might be helpful to think of this as a mixed number. And we know, we've got 3 and 1/3 is what this is equivalent to. Again, 3 and 1/3. All right, so we're going to go over here. We go to the 3, and then go about 1/3 the distance. And we'll call that B. All right. Okay, so now the plot thickens a little bit. We've got all these guys here. Note that x cannot, before we even begin, it's worth noting that we can see that x cannot equal negative 1. We can see that x cannot equal positive 1 either. Now, how do I know that? By looking right there. What happens if I plug negative 1 into there? Well, I'll be dividing 1 by 0. I can't do that. What happens if I plug positive 1 into here? Well, that means I'm, again, 3 dividing by 0. I can't divide by 0. If I put a negative or a positive 1 into this guy here, well, I'm dividing 10 by 0, and I can't do that either. Before moving forward, I would urge you to take a second look at A and B here and just see, well, what numbers of x were not allowed. Because that is something you want to check. Because if we end up with a solution that is one of those numbers, then it will not work. And if you've already checked it for A, we couldn't put in 0. We end up with 1/3, so it was fine. Here we, again, could not put in 0, but our answer was not 0, so again, we were fine. All right, so let's work this one. What's the lowest common multiple? Well, note that x plus 1 times x minus 1 will get me this value right there. So the lowest common multiple is, in fact, x plus 1 times x minus 1, or x squared minus 1. Okay. And if you're having trouble seeing why that's true, just multiply these two together and make sure you get this right here. All right, so let's go ahead and work this through. We're going to go ahead and put x squared minus 1 here. Make sure you put parentheses around that, because if you were to write it like this, you are saying something different. You're saying this guy is being multiplied by x squared, and then when all that's done, you're subtracting 1. That's not what we're doing. We're multiplying the whole thing, so make sure you use your parentheses. All right, and then over here, this is x plus 1 times x minus 1. Okay, so let's go ahead and work these. And then on the other side, well, we can already see that that's going to cancel with that. And so right-hand side, we're left with 10. Now on the left-hand side, again, we've got x plus 1 times x minus 1, x plus 1 times x minus 1. So we cancel out. What cancels? X plus 1 to the x plus 1, x minus 1 to the x minus 1. And you may note that I'm not using parentheses here and here. It's not really necessary to put them on here, but it is necessary to put them on these guys. Okay. So what are we left with? We're left with x minus 1 on this one. I'll go ahead and put parentheses on there for emphasis. Again, it's not necessary. And then over here, this is x plus 1 times 3. And that all equals 10. Okay, so make sure you maintain these parentheses, because this 3, oh, and this one you don't have to maintain. This one, it is important, because we want to make sure that we show that 3 has to multiply to the x and the 1. So let's go ahead and simplify this out. So we have x minus 1 plus 3x plus 3 equals 10. And so we've got an x here and a 3x here. Those guys combine to make 4x. And then we've got just two constant numbers, a negative 1 and a positive 3 there. And when you combine those, you get a positive 2, and that all equals 10. Okay, so far so good. Alright, so we subtract 2 from both sides, and we're left with, I'm going to go ahead and carry this over here, 4x equals 8, divide by 4, and we get x equals 2. Okay, so there's our answer. Let's go ahead and plot that one. That is a natural number. And we're going to put that one right there. All right, cool. All right, so let's take a look at D. Right off the bat, let's take note. What can x not equal to? Well, it can't equal, we look at this one, it cannot equal negative 3. When we look right here, it cannot equal positive 2. And note that if I multiply this together with this, I'm going to end up with this equation right there. If you cannot see why, go ahead and work it out on your own to make sure you get it. And keep in mind, you will be using the FOIL method when you do. Make sure everyone gets to multiply with everyone. Okay, so that's our lowest common multiple, is all of this over here. So let's go ahead and multiply both sides by that. And then over here, this is simply x plus 3 times x minus 2. All right, very similar pattern. This cancels with this, and then we're going to come over here on the left-hand side, and we're going to distribute. All right, so we've got our 2 over x plus 3 plus, minus 1 over x minus 2, and that's all going to equal 2. All right, now let's go ahead and distribute, write in what we're distributing. X minus 3, x minus 2, x plus 3, and x minus 2. All right, so we cancel out what cancels. X plus 3 gets rid of x plus 3, and x minus 2 annihilates x minus 2. All right, so we've got 2 times x minus 2, so that's going to give us 2x minus 4. And then over here, it's x plus 3 times 1, so it's just x plus 3. Now I just wrote a very common mistake. Take a look at it, try and figure, if you can't see it right away, kind of try and look at it for a moment. I'm going to go ahead and show it to you now, so hit the pause button if you want to find it on your own. The mistake was right here. That should be a minus, because you want to make sure you distribute this negative to both the x and the 3. Okay. Oop, didn't mean to erase that one. There we go. All right. And that all equals 2. All right, so we got a 2x and then a negative x. And so 2x minus x is simply x, and then we've got a negative 4 and a negative 3. Add those two together, and we'll get a negative 7. Again, that all equals 2. And then move that over by adding 7 to both sides, and we find that x equals 9. Okay. All right, so that's our answer. We'll go ahead and plug that in, right off the scale. It'll be right here, and that is our D. Okay, well that's it for the handout here. We started off the handout in part 1 by going over the story of number sets. And we talked about what it meant to be a natural number. You know, natural number is just any number you can count to and you can naturally see with your eye. Integers includes 0 and all the negative numbers. Rational numbers is the ratio of any two numbers. Keep that in mind. And then real number is simply any number that will exist on the real number line. And then complex number encompasses everything in the complex plane as well. And that would be any number that takes the form of a plus b times I, where a and b are both real numbers. Modern day application for classifying numbers is saving memory in your computer. When you declare variables, if you declare your variable as a real number, the computer will store all the decimal places, jamming up memory. But if all you need is just to count from 1 to 100 for in the computer as it goes through some iteration, it's best to declare your variable as a natural number. And so that's one way these guys are used in the in practice. Okay, so that covers the review of part 1. Part 2, we went over linear equations. A linear equation can have one solution, or it could have infinite solutions, or it could have a no solution. All right, we also talked about being careful not to divide by 0. And then we worked through some rational equations. All right, well that's the first handout of the semester. I hope you got something out of this. But mainly this should have been a review. There might have been a few things that you hadn't seen for a while, but that's, if you're a little rusty on that, that's okay. If you have questions, please send me an email. I do my best to respond as quickly as I can. Just Don't expect a quick response if you send it at 1 a.m., but I will do my best to get to it the following day. All right, have a good one, class.